Okay, here's a little practice for our Unit 2 exam. It says here that Lisa has at most $100 to spend on clothes. She wants to buy a pair of shoes for $42 and spend the rest on t-shirts. Each shirt costs $12. How many shirts can she buy? First step is to write an inequality. All right, well, let's see what we have. First of all, we need to make a variable here. We're trying to find how many shirts. So let's just make X equal the number of shirts. It's the number of shirts she can buy. All right, well, let's see what we have here. It says Lisa has at most. Hey, wait a minute. At most means less than or equal to. She has at most $100 to spend. So what we'll do is we'll set this up as less than or equal to $100. It says she wants to buy a pair of shoes for $42. Okay, well, that's one thing she's going to have to spend money on, $42. And the rest on t-shirts. Now, each shirt costs $12. Okay, wait a minute. X is the number of shirts. And the cost is $12. So the number 12 goes with shirt. Shirt is X. So therefore we have 12X. So this and this, the $42, has to be less than or equal to $100. Next, we need to solve the inequality. So going back here for a moment. So remember, most students have difficulty defining which number goes with the variable. And in this case, you just look for what you're looking for. Shirts, they cost $12, so 12 goes with the X. X is shirts, 12 goes with the X. All right, so now we need to solve. So I will subtract 42. That's gone. That's going to give us 58. Bring down the 12X. And next I divide by 12. That's gone. And we get X less than or equal to. Okay, there's many ways you could do this right here. I'm just going to reduce it for now, make it a little smaller numbers. And we can see, I know that 2 goes into both of these. All right, well, half of 58 is 29. And half of 12 is 6. So 29 over 6. And I know that 6 goes into 29 4 times with 5 left over. So 4 and 5, 6. Now I could have did this a decimal. I could have divided and made it a decimal. I just chose to do it this way. Okay, so the question now is, so I solved it. And the question is, how many shirts can she buy? Well, it has to be less than or equal to 4 and 5, 6. So she can't buy 5 shirts. It must be 4 shirts. So she can buy 4 shirts. She can't spend any more money than $100. You can't buy 4 and part of a shirt, only 4 shirts. And for those of you who like to model this, this would be 12X (42) less than or equal to 100. That would be our model for this. But you're not required to make a model here on this assignment. All right, let's go to the next question. It says Andrew wants to buy 2 watermelons and some apples. Now the price of 1 watermelon is $4.99. The price of apples is 47 cents a pound. Andrew wants to spend less than $15. Okay, write an inequality that represents the number of pounds of apples, letter A, Andrew can buy. Okay, well right now we already know what A is, right? We just defined our variable. A is going to be the number of pounds of apples. So I'm not going to rewrite that because it's right there. Okay, so let's see what we have here. First of all, he's going to buy 2 watermelons, it says here. 2 watermelons. Okay, well, 1 watermelon is $4.99. Oh, you know what? I'm just going to change that. Let's round that up to $5. That's ridiculous. I'm just going to say 5. All right? And he's buying 2 of those. So he's going to buy 2 of those for $5. Then he's also going to buy apples. Let's see how many apples. Some apples. We don't know how many. And they are 47 cents per pound. And we said apples gets the letter A. So that's going to be, hey, wait a minute, 47 cents. Let's kind of round that up. Let's make that 0.5, 50 cents. So let's just make it 0.5. So this is going to be 0.5, and then A is for apples. Okay, and then it says that Andrew wants to spend less than $15. Well, less than 15. So let's see if we got this right. 2 apples, and apples we're saying are $5. 2 watermelons, and they're $5. And then some apples, and apples are, and we just said 50 cents a pound. 50 cents a pound. So here's our inequality. Next, we need to solve the inequality. So let's see. Well, let me just simplify. 2 times 5, that's 10. I'll bring the rest down. You can make this 0.50 if you want, but let's try and make it easier. All right, next step is to subtract 10. Bring the rest down. So 0.5a less than 5. So you can do this many ways. I'll just do it the way that we're used to doing it, and that is I would simply divide this coefficient by 0.5. Okay, so that's gone. And now you have a is less than whatever this is. Some students have difficulty with this. So if it was any other weird number, we would simply divide. We take the top number, put it in the box. So I'll do that to the side. Again, there's easier ways of doing this, or you can even look at it and tell, some people. There's my 5, and here's a 0.5. Now, I need to move this over 1 space. So here's a decimal here. I would move it over 1 space, and then bring it straight up. So really what I have is 5 into 50. 5 goes into 50 10 times. So this is 10. Again, there's many ways of doing this. So A is less than 10. So what does that mean? That means he has to spend less than $10 for apples. Or less than 10 pounds, sorry. Because remember, A is the number of pounds. So he's going to buy less than 10 pounds of apples. Down below it says, draw a graph that represents the number of pounds of apples Andrew can buy. All right, so you know what? I'm just going to make a quick little number line. Here's 0, and here's 10. $10. Okay, this is all dollars. So let's see. He can't, I'm sorry, it's not dollars, is it? It's pounds. Because remember, A is the number of pounds of apples. Okay, so this is pounds, excuse me. So, can he buy 10 pounds of apples? It says less than 10. So the answer to that is no, he can't buy 10 pounds. So I'm going to put open circle. But he can buy less than 10 pounds. Hey, wait a minute. Can he buy 0 pounds of apples? If he wants to buy some apples, is he going to buy 0 pounds of apples? No. No, he's not. So any of this would be the solution. All right, sorry for the sloppiness. Let's go on to the next problems. Now we get into distributive property. So remember, you just take the outside times each one inside. So this is 5 times 3x. And this is 5 times, that's a negative 1. That would make negative 5. And there's your answer. Okay, the next one. Again, take the outside times each one inside. Hey, we already did that up above. This is 15x minus 5. Okay, now I'm going to take the outside times each one inside. Wait a minute. This is a negative 4. So negative 4 times 2x. Negative 4 times 2 is negative 8. So that's negative 8x. Then I do negative 4 times negative 1. Negative 4 times negative 1 is positive 4. Because 4 times 1 is 4. Two negatives cancel when multiplying. All right, now we need to combine like terms. So let's put the x's together. Notice how I'm circling that's a negative 8. Well, 15 and negative 8, that's 7. $7x. All right, now we need to put the numbers, the constants together. Here I added the coefficients. Now I'm going to put together the constants. Negative 5 and 4. That's negative 1. And there's your answer. Excuse me. So that's 7x minus 1. All right. Next one. This is a little bit different. We don't have a coefficient with an x right away. It comes later. That's all right. So let's see. We're going to do 2 times 4, and then 2 times negative 5x, or negative 5. Well, 2 times 5, negative 5 is negative 10. Now, this could be written differently. You could move this around, because it's customary that we not write it this way. It could be written like this. See that? They're the same thing. So try not to let that confuse you. The last one here. What's the value of W? What's this number? Well, let's see. If I take 3 times 2, that's 6x. Okay? Well, that's this right here, 6x, isn't it? Okay? Then I have 3 times negative something. Well, that negative something must equal negative 12. 3 times negative something equals negative 12. What would that be? And if you didn't know, 3 times negative something. And so 3 times, and it has to equal 12. 3 times negative something equals negative 12. Well, if I divide by 3, and that would be, you already know the answer, I'm sure. Negative 4, and that's negative, divide by negative 1, and that would give us positive 4. So if you did not know, you could probably tell by looking at it, but the answer is 4. And let's see if that works. Again, you can always do trial and error. If I put a 4 in there, will that work? 3 times negative 4 is negative 12. That works. Okay, so sometimes they may mix this up, just like this here. Don't let that confuse you. Okay, so hopefully this has helped you, and good luck on your Unit 2 exam.